Hello and welcome to AI for Developers. I'm Chaitanya talking bot. Today's lesson is titled AI Architecture and Scalability, Building Robust Systems for the Real World. Imagine you're building a massive amusement park. You don't just plop rides down anywhere. You need a blueprint, an asterisk architecture. Similarly, for AI, architecture is the master plan for how all its parts work together. And scalability? That's making sure your park can handle 10 visitors or 10 million without crashing. For developers, understanding this is key to building AI that actually works in the real world, not just in a demo. Think of an AI system like a fancy restaurant. 1. The data, ingredients. This is the raw material, text, images, numbers. Just like a chef needs good ingredients, AI needs good data to learn from. 2. The AI model, the chef's brain. This is the smart part. It's like the chef who learns recipes and techniques. It takes the data, finds patterns, and makes predictions or decisions. 3. The infrastructure, the kitchen and dining room. This is where everything runs, the servers, computers, databases. It's the physical space and tools that let the chef cook and serve. As a developer, you'll touch all these parts. The AI model is where the intelligence happens. Training, learning. Imagine teaching a kid to identify cats. You show them thousands of pictures of cats and not cats, saying, "This is a cat," or "This is not a cat." The kid, model, learns the patterns. In development, we feed data to the model, and it adjusts its internal knobs, parameters, to get better at its task. Inference, doing. Once trained, the kid can now see a new animal and confidently say, "That's a cat." The model takes new, unseen data and uses what it learned to make a prediction or perform a task. As developers, we deploy these trained models for others to use. Your AI model needs a place to live and run, just like your chef needs a kitchen. Cloud, rented kitchen. Services like AWS, Azure, Google Cloud. You rent computing power and storage. Scaling up or down easily. Great for flexibility and large projects. On-premise, your own kitchen. You own and manage your own servers in your data center. More control, but more responsibility. Often used for sensitive data or specific hardware needs. Edge, food truck. Running AI directly on small devices, phones, smart cameras, drones. Ideal for real-time processing or when internet access is limited. As a developer, you decide the best home based on your project's needs. An AI model is only as good as its data. A data pipeline is like a conveyor belt that reliably brings ingredients to the chef and takes out the finished dishes. Ingestion, collecting data from various sources, databases, websites, sensors. Processing, cleaning, tidying up the data, removing errors, transforming it into a usable format. This is crucial for model performance. Storage, safely keeping the data in databases or data lakes. Serving, delivering data to the AI model for training or inference, and then delivering the model's outputs, predictions, to users or other systems. As developers, we build and maintain these pipelines to ensure fresh, clean data. Scalability means your AI system can gracefully handle more users, more data, or more complex tasks without breaking down. Imagine a single chef versus a whole kitchen brigade. If your restaurant gets popular, one chef won't cut it. You need more chefs, more ovens, more waitstaff. Asterisk in AI. This means horizontal scaling, adding more identical servers or instances to spread the load. More chefs. Vertical scaling, upgrading existing servers with more power. A bigger, faster oven. Good architecture anticipates growth. As developers, we design systems from the start to be scalable, using tools like load balancers and distributed databases. Building a real-world AI system is more than just making it smart and scalable. Reliability. Does it work consistently? What happens if a server fails? We build in redundancy and error handling. Monitoring. Can we see if it's running smoothly? Are there bottlenecks? We use dashboards and alerts to keep an eye on performance and catch issues early. Security. Is our data safe? Is the model protected from misuse? We implement robust security measures to protect sensitive information and prevent unauthorized access. As a developer, these are critical non-functional requirements you must consider from day one. We've covered the blueprint of AI systems. Architecture, how to feed them data, where they live, and how to make them grow. Scalability, remember the key components: data, model, and infrastructure. Understanding these fundamentals empowers you to build robust, practical AI applications. Keep exploring, keep coding, and see you in the next lesson. Thanks for watching. If you found this helpful, make sure to subscribe to our channel and hit the like button.